numbers. These are also part of the number systems in which we should become accustomed. We're going to begin by reviewing the numbers that we already know. You should go ahead and copy down numbers into the charts that you already know. Natural numbers. These are the numbers that we use for counting, like 1, 2, 3, 4, and so on. This continues to infinity. Whole numbers. This adds on to the set of natural numbers. That's why when you look at our chart here, natural numbers are inside of the whole numbers group. Whole numbers, however, only includes one extra number. So in the grand scheme of things, it's not much larger. It includes the number 0. So it's 0, 1, 2, 3, 4, and so on, going up to infinity. The integers. These are all of the negative and positive whole numbers. These are numbers going from negative infinity to positive infinity, such as -3, -2, 0, 1, 2, 3, so on and so forth. Encompassing the natural numbers, whole numbers, integers, we have rational numbers. Rational numbers are fractions or decimals that terminate or repeat. Terminating means that it has a stopping point. Repeating means it has a pattern that we can recognize fairly quickly. Any number that can be written as a fraction, so all of the integers, all of the whole numbers, and all of the natural numbers, as well as numbers like 1/2, 2/3, 4/7, and decimals that terminate or repeat. Decimals like 1.6, or repeating decimals like 1.3333 repeating. These are rational numbers. Off to the side here, we have irrational numbers. These are non-terminating, non-repeating decimals. The most common forms of non-terminating, non-repeating decimals are non-perfect square roots, such as the square root of 2. Pi is also an irrational number. It's probably the most famous of irrational numbers. Rational numbers and irrational numbers make up the real number system. In connection with the real number system, we have imaginary numbers. Imaginary numbers contain the number I as well as complex numbers, and complex numbers are in the form A plus BI. Remember, you've already watched the previous video on the powers of I as well as the introduction to writing complex numbers. A is the real part and BI is the complex part of a complex number. Now we're going to begin talking about operations with complex numbers. We're going to start out with adding and subtracting. When you add or subtract complex numbers, you add or subtract the real parts to the real parts and the complex parts to the complex parts. What that means is anything with an I gets added or subtracted to anything else with an I. Anything without an I gets added or subtracted to anything else without an I. Our example here with just letters, A plus BI is one complex number. We are going to add to it another complex number, C plus DI. So the real parts, A plus C, get added together, and the complex parts, B plus D, get added together. And I'm bringing along the I. These are like terms. That's why I can add them together. In my example with numbers, 3 plus 2i is one complex number, 5 plus 3i is another complex number. 3 plus 5 is my real, 2i plus 3i, I'm only adding the numbers because these are like terms. 2 plus 5 becomes 8, 2 plus 3 becomes 5. Our new complex number is 8 plus 5i. when we multiply complex numbers, we generally want to use the FOIL method, but we can also use this method here if you can remember this formula. A plus BI, when multiplied by C plus DI, we multiply AC and subtract from that BD, and then we're going to add that to BC plus AD, and we're going to bring along an I. So how does that work with numbers? I know that's kind of confusing because that was all letters there. So we have 3 plus 2i, and I want to multiply that by 5 plus 3i. The same problem as before, but now I'm multiplying it instead of adding it. So I take 3 times 5, and I'm going to subtract from that 2 times 3. Then I'm going to add that combination to 2 times 5 plus 3 times 3 with an I. 3 times 5 is 15, 2 times 3 is 6, 2 times 5 is 10, 3 times 3 is 9, so I'll have 15 minus 6, which is 9, 10 plus 9, which is 19, and this 19 brings an I with it, so I will have 9 plus 9i. Here's the same problem, but as viewed with FOIL. We use our first, outer, inner, and last. Our first terms, 3 times 5 is 15. Our outer terms, 3 times 3i is 9i. Our inner terms, 2i times 5 would become 10i. Our last terms, 2i times 3i would become 6i squared. And we have a note here. Remember that I squared is equal to -1. So when we put it all together, we will have 15 plus 9i plus 10i plus 6 times -1. 15 minus 6, because we're going to add our like terms, 6 times -1 is -6, will give us 9. 10i plus 9i is 19i. So now I have 9 plus 19i. It's the same result as what we had in our previous problem. You have 2 problems on your guided notes page to answer. We'll discuss these tomorrow at the beginning of class for our bell ringer activity. Please make sure you have them completed.